So first, let's begin this workshop with a presentation from Vincent Chalias. Vincent, are you ready?
Yes, I'm ready. Whenever you guys ready, I'm up for it.
Okay, great.
Should I share my...
Yes. Yes, Vincent, go ahead.
Okay, share. There you go. And can you see my screen?
Yes.
Okay,
Perfect.
fantastic. So hello everyone. Thank you very much for inviting me, to share my experience with you people. I hope this is going to be helpful for a lot of people. So I will try to keep it to talk as slow as possible so the translator, can translate for you. And how does that work now? Okay, here. So first of all, I used a little bit of references for all my courses, and then I wanted to share a few with you. The first one is a guide to coral reef restoration, which is pretty new. I think is made by the Nature Conservancy also, and the Coral Restoration Consortium. You can find it online. It's free access, and it's a lot of information into it. The second one is the Manager Guide to Coral Reef Restoration Planning and Design. It's a little bit older. It was done by the Nature Conservancy, but also has a lot of information. And the last one is, the Coral Reef Resilience in the Anthropocene. It's a very interesting book, about how to anticipate ecological change and shift in coral reefs. So I highly recommend, to consult those references. Yeah. So this is the content that I'm going to go through, explaining you, sharing my experience that I've done over the last 25 years. So about me, I participated in creating the first in-situ commercial coral farming in 2002. I started also the first Indonesian ex-situ commercial farms in Indonesia. So I spent over 15 years in the commercial sector, farming corals for the aquarium industry. And as I always used to say, the difference between this commercial farming and coral reef restoration is in commercial farming, if the corals die, you don't get paid. So we had to farm corals, keep them alive, and ship them all the way through halfway across the world. And only if they arrive alive over there, then we would get paid. So it's a very different mindset than most NGOs. I farm over 800,000 corals during my commercial career, and then I planted over 200,000 corals here in Bali and in Indonesia. And last year I set up a 230,000 coral nursery in Saudi Arabia. So I did plant quite a lot of corals. I started my career in reef restoration in 2016, but when we did the regulation for in-situ coral farming, 10% of whatever we produce was meant to be used for coral reef restoration. So as soon as I start commercial farming, we were starting to do coral reef restoration. Unfortunately, the coral that are produced for aquarium are not really the coral that are needed for coral reef restoration, as we will see a little bit later. So since 2020, we planted 200,000 corals here around Bali. And I worked all over Indonesia. I worked in Great Barrier Reef. I work in Saudi too. So first, there is some few facts. So the idea is to make people realize that there is not one solution for all. There is no magic bullet. And to restore a coral reef,
Untuk membagikan bahwa tidak hanya satu solusi yang dapat digunakan untuk merestorasi karang.
Over 1,500 different fish species on the coral reef. There is 500 to 600 hard coral species, probably even more of soft corals, 100 of different coral assemblage and habitats, 10 of varying substrate composition. So especially here in Indonesia, you have a lot of bays and capes, you have a lot of currents, you have protected, exposed, a lot of different habitats for corals. There is a lot of substrate from rubble, sand to rock, shallow reef, lagoon, etc., etc. Causation of flow, tide, wind, temperature, and wave combination that change daily. So there is coral reef are insanely diverse. So imagining that we can restore coral reef using only one method is being unrealistic. There is one concept that is very interesting in coral reef is what we call shifting baseline. I give you this example. This is from a friend of mine, you know, that his name is Phil Dustin, that started taking pictures of Caris Fort Reef in Florida since 1975. And you can see as it started in 1975 as the field of Acropora palmata, and now it's just bare rock. So this is basically what is happening in Indonesia, and I can already see. I've been diving in places for over 25 years, like in Northeast Bali, in Tulamben and Amed, and I've seen this shift. So it's always what I explain to my students. So my baseline for dive site is my first dive there, and the baseline for my students is their first dive there. And there is 25, 30 years difference between that, and the baseline is very, very different. I can see already so many fish disappearing, and I can see already so many corals disappearing for the dive site that I've been diving for the last 25 years. Another issue that the coral clock, you know, I call that, is that the time for corals is very different from the time from humans. And you need to take this into consideration when you're doing coral reef restoration. 50 years of our life is a single minute for coral. They can live forever. They don't age. Their DNA doesn't deteriorate. So they don't live in the same mindset as us. They live very differently. So doing coral reef restoration and having 2 years plan and target is meaningless, because for coral is only a few seconds. So when you do coral reef restoration, you have to have long-term targets, 5, 10, 15, 20 years. And you have to imagine that the coral will grow for 5, 10, 15, 20 years. What size it will be in 5 years, what size it will be in 10 years, what size they will be in 15 years. Are they gonna start fighting each other because they grow to a certain size, and then they start meeting each other, and then they start fighting each other? So you have to take all this into consideration. So for all those reasons, there is no single magic bullet. Thinking that using one single method of coral reef restoration is going to work all over the world for all the different species of corals, it's being delusional. So there is no technique that works for all the different species of corals. There is no technique of coral reef restoration that can be used in all different habitats. Every technique has advantages and disadvantages. So when we do coral reef restoration, we cannot stick to only one method. We need to use a broad set of techniques, which include sexual, asexual, etc., etc. So we will go through different techniques that I've been experimenting. So this is what I call the toolbox, and this is what I try to teach my students, is I try to get them to try as many techniques as possible during our courses. So a broad set of techniques for various animals, various conditions, and various habitats. Selecting the best technique according to the site condition, species, substrate, flow, wave, etc. is primordial in trying to achieve a proper result. So then the result will evolve in time. So evaluate natural recovery. So you need to have a control and a restore side to know if really all your techniques are working properly or not. And if they're not, maybe you can adjust and fix the result. The outcome can greatly vary over time. So I've seen coral reef restoration, usually, especially when they mix species close to each other, it looks fantastic after 2, 3, 4 years. And after 5, 6 years, they start to grow and start to meet each other, and they start to fight each other and kill each other. And so after 2, 3 years, you have a very broad diversity of species. And after 5, 6 years, you have one species that take over and dominate all the other one and kill all the other one. So depending on the time when you look at the results, you will have very different results. So the idea is to target the result as far as possible in time and monitor the result regularly. On the right side of the slide, I show you, this is Rotiboya. So this is some piece of concrete that have been dropped on the ocean floor in Bondalem, North Bali during COVID. This was part of ICHEAG. So they just put some cement, and you can see the restoration result is actually very nice. You have a very high diversity of natural recruits. They didn't plant one single corals on those concrete. But if you go 500 meters upstream in the bay, there is nothing growing on the same concrete structure, you know. So depending on what kind of material, and just putting the right material in the right location is often just good enough to do coral reef restoration and to have natural recovery. And this is always what we have to anticipate, and always what we have to promote, the natural recovery.
Ini juga yang mereka lakukan untuk pemulihan alami.
So there is different methods. So this is the one that I use in Penida. So we use wooden stake and cotton rope. So this is organic result. So you can see we have very good result, especially with branching acropora. So it's probably the cheapest coral reef restoration in the world, but it will not work everywhere. And Nusa Penida is a very forgiving site, has a very good current, very good environmental condition. And yeah, the branching corals, this is mostly Acropora pushra, and all the branching community of Acropora love it. This is another one. So this is what we've been doing here in Raja Ampat. We call this substrate stabilization. So we use just mesh size. Sometimes we seed them with corals, sometimes we don't even seed them with corals, and often we have roughly the same results. So you can see was large rubble field on the steep slope, and we just use wire mesh nets over the slope to stabilize the substrates. And as soon as you do that, and as soon as the rubble slope is stabilized, you start to have coral growing. So in some of places we seed them, some others we don't seed them, but this is a very simple and very low cost, very efficient system, but that will only work on steep rubble slope. Here I give you two examples. On the left side is also in Nusa Penida. This is a reef star or spiders, a metallic structure. So you cannot see them anymore. You can see it has been very successful and worked very well. On the right side, this is our rack nursery where we produce fragment to actually outplant. And you can see using metallic structure, if it's used right, it can work also very well. Here I give you some more example of, so on the left we have what we call fish domes, and on the right we have pyramids made out of concrete cubicles. So both of them used in the right place. Both of them were not seeded with corals, and you can see this is only natural recruitment, and both of them work very well. So there is not one method, you know, that works better than the other one. There is just the right method for the right place for the right species. So here I show you another one. This is what we do. We do outplanting. So we take fragments from our nurseries and we outplant them using cement. So we just use cement and we outplant them. We do a lot of maintenance on those ones to get rid of all the drupella and the crown of thorn starfish, so they don't eat the newly planted fragments. But the result is also good. So all this to say that there is no bad method. There is just the right method for the right place, and there is differences between a good and bad project. So I stole that slide from my friend Arno from the Sea People. So there is a lot of aspects that enter into a good and a bad project, and I just want to show that most of the project, unfortunately, they only concentrate on one aspect, which is the restoration itself, so physical degradation and destruction from human activities. And unfortunately, this is not enough. And there is a lot of other things that you need to fix before you can actually restore reefs. So you need to, there is only so much you can do when it comes to climate change, but there is still some few things you can do. You can increase diversity, and you can reduce other stressors, you know, so they don't become add-ons on the bleaching events. There is a lot of local and regional pressure where you can actually be active on, so you can control destructive fishing you can, this is more difficult to control the coastal development. You can control rapid growth in marine tourism and associated pressure. So this is what we're trying to emphasize in Nusa Penida and Raja Ampat. You can do coral reef restoration, and after you can do all the social aspect of coral reef restoration, which is using communities and employing local peoples to actually take ownership of their own reef. So this is one key, and it has been published already in many different publications, involving local communities and let them employing and training them to do the coral reef restoration on their own reef and getting the benefits of the coral reef restoration for their own is actually key to success in coral reef restoration. So planting coral is just a small part of successful coral reef restoration. So it's a long way. I think TRIS has been going through that. So it's a long way before you even start planting corals. So you need to set program goals. You need to check with all the stakeholders in the surrounding of the site. Look at access, map surviving donor corals. So you need fragment to start a reef restoration project. So you need to make sure you have fragments available. I will give my small rant on fragments of opportunity. I don't support breaking a reef to restore another reef. Fragment of opportunity is a very sensitive subject. I think, unfortunately, corals, especially branching corals, you know, asexual reproduction is their main mode of colonization, you know. So it's not because you find a fragment on the seafloor, you know, that is not going to survive. And even after more than 25 years of experience, you know, looking at it, you know, it's often very difficult for me to guess if this coral is going to make it or not. So I'm always surprised, you know, by some fragments, you know, that actually made it. So the problem of fragment of opportunity is one big issue, you know, and I don't support people that are destroying a reef to restore another one. So you need to identify nursery site. So the first fragment of opportunity, you will use them to actually develop your own nursery. So you build and deploy a nursery platform, you collect fragments from donor colony, you mix the genotypes as much as possible. A nursery is not a fixed thing, so you start a nursery with some species. When you have planted enough, you can change the species that are on the nursery, so you can increase the genetic diversity and the species diversity also on the nursery. Then you deploy fragment at nursery, you propagate corals at nursery to maximum productivity. Running a nursery, you can use already a wide set of techniques, from land-based nursery to in situ nursery, using ropes nursery, using rack nursery, using microfragmentation, etc., etc. There is many different techniques. And usually it's better to use a broad set of different techniques. Then after you maintain your nursery, you expand it, and you identify your plant reef set, and you start outplanting. So it's a long process before you can start even outplanting. And then when you start outplanting, you have many other things to do, you know, so it's a long process also after the planting has started. So you start, I usually say, you know, you start with the foundation corals. So you have to identify which one. It's usually species of Acropora, Antipora, Echinopora, often that are the foundation of the reef. So you plant those one first, and once the foundation is going, you add the other, you increase the diversity and you add the other species. So increase coral abundance and cover. Sometimes you don't even have to plant much, you know, sometimes just maintaining the reef and doing some gardening, you know, is enough to actually get coral reef to come back. Enhance coral sexual reproduction. So I highly recommend my students, for example, you know, to plant same species, different genotype next to each other. So when there is a spawning event, they can fertilize each other. Rebuild the trophic structure, increase connectivity, restore reef structure, restore fish and invert habitat. This is important. Create genetic and genotypic repositories. So you have many species of the same, many genotype of the same species. Identify resistant and susceptible holobiont or reef habitat. So this is often very important to start the nursery phase, increase species richness. And then after, there is coral for research, coral local conservation, improve diving, alternate livelihood, ecotourism. So this is all the the indirect benefit of coral reef restoration. And then after, the long-term goals contribute to species recovery, build reef resilient, restore reef ecosystem services, coral hardening, assisted mitigation, assisted evolution. So the target is far away, so you have to restore reef in a way that they will be able to support future conditions. So most common mistakes that I see, so I always say location, location, location. Selecting the wrong location, it's usually the main mistakes. Then the cause of destruction not removed. I always talk about the silent killer, which is sewage water. We see in Raja Ampat is a very big problem right now. With increased tourism activity comes a lot of sewage and a lot of nutrients intakes into the reef ecosystem, which brings a lot of problems on top of climate change and bleaching. So this is a kind of problem that can be solved. Over tourism, regulation of tourism, diving is easily controlled. Destructive fishing can be controlled. After, there is some few things that are a lot more difficult to control. So proper long-term ecological survey. So one of the big mistakes that I see is planting the wrong species in the wrong place. Unfortunately, corals are very adapted to their ecosystem. There is no luck in coral reef ecology. If a coral grows somewhere, there is a reason for it. It's because it's the most adapted to that particular environment. So you need to understand that the coral species that are adapted to the top of the reef, cannot grow in deeper water. Coral that need flow cannot grow in protected area. And often, if corals like Isopora, for example, is a wave buffer, so it's gonna control the wave action on the reef. So if you don't restore the wave breaker first, that is made of Isopora mainly, then everything that is behind is not going to survive every time there is a storm. So you just need one storm a year, to destroy all your efforts. So there is, it's very important, so especially I've seen a site recently, that made a lot of noise in Indonesia, where they restore. There was a cruise ship that hit one of the reef in Raja Ampat, and it took 9 years, for them to start doing the reef restoration work. Unfortunately, they came at the worst time possible, because they did this work in March. So the coral start bleaching in November, December, January was heavily bleached, and February, March, they were just starting to recover a little bit, and this is when they started the reef restoration project, and they moved coral fragments that were stressed onto the new reef stars, and unfortunately many of these didn't survive. So the timing is really important. Don't start reef restoration work when coral are stressed. I will highlight that before bleaching, few months before bleaching, the corals are already stressed. So not only you have to stop reef restoration work before the bleaching, and you have to wait long enough for the corals to recover before you can start anything. The regulation check, there is more and more regulation in place. Indonesia is starting to promote what they call KPKRL, which is a regulation that regulate the use of seafloor. So this is, you need to have these licenses before you start any reef restoration work. You need community support, and you need to involve communities. You need to train them, and you need to employ them, and let them take ownership of the project. Then you need to put maintenance routine. So the minimum, I think, is 2 years maintenance. So meaning going down on the reef at least once a month and check for Drupella. Often a Drupella infested or corn of thorn starfish infested reef. On a rubble zone, you can have Drupella sleeping inside the rubble, and as soon as you plant one coral in the middle of it, then they will come out and start feeding on the corals. So if you don't remove Drupella, if you don't remove the cushion starfish, if you don't control the triggerfish, if you don't control many animals that will actually target your corals, we know now that Drupella and corn of thorn starfish are attracted by stress corals. So they can smell stressed acropora and they can quickly find them among a large field of rubble. One common mistake that I see is coral are social animal, and usually when you have a large area of coral rubble, people start planting in the middle of that area. This is usually doesn't work very well. It's better to actually start planting coral next to healthy coral reef and work your way down into the empty area. So coral that you plant benefit from the protection of healthy corals. So usually that works a lot better. So maintenance and long-term financial support. Usually what happens is that there is no funding anymore to actually do the maintenance or to fix mistakes. So this is very important. One of the problems that I see is that a lot of a lot of people that start coral reef restoration don't understand proper coral ecology. So when we train people, we give them 1 week coral ID, and this is, if you don't know the difference between a banana tree and a pine tree, you know, gardening is going to be difficult. So it's the same thing with coral reef restoration. Most people work with acropora corals. Acropora, there is 120 species, probably around 400 once the genetic work is made around them. So they live from 0 to 120 meters deep. And if you start planting the species that lives 120 meters deep in 2 meters of water, that's not going to work. If you plant the species that is specialized in living under the waves, you put it in a turbid protected bay, that's not going to work, etc., etc. So it's very important to respect the ecology of corals and plant the corals where they belong, which is a new science, and not many people are properly trained in coral reef restoration to actually understand properly coral reef ecology. Trying to restore them without proper reef ecology basic can be challenging, and understanding is key to fixing. So understanding of the mistake that you've made is actually the way to fix it. Building resilience. So you want coral reef. So as we say, the target is over 10, 15 or 20 years, and you want the corals to withstand, you know, for 10, 15, 20 years. So we have many different techniques. You can change species, so you can move acropora dominated reef to a porites dominated reef that will withstand higher temperature, or you can also select the site that will be close to upwelling, close to deep water, and will have better environmental condition. And you can also select that coral that have genetics, you know, that make them more resistant, tolerant, or resilient. So assisted adaptive evolution must be applied. So a bleaching event is always a selection process. So it's just a way to select the most adapted coral. So you lose the weakest one, but you keep the strongest one. And using those strongest one to actually do the coral reef restoration is key. So using stress lab, working on the genetic of resistant coral is the key to successful coral reef restoration work on the long term. Coral gardening. So if you don't need to plant coral, this is always the best solution. A natural recovery is, but coral gardening is always what I promote before doing mass coral reef restoration. So just by going after a storm, going after anchor damage and securing the loose corals using concrete, using cable ties, using nails, there is different techniques, using epoxy. There is many different techniques that can help you. The project that we saw involving this cruise ship accident, if they would have been there the next day of the accident and would have secured all the corals boulders and all the broken coral that were lying on the floor, they probably would have saved most of them, and probably that no reef restoration work would have been necessary 9 years later. Okay, so being active after bad weather and being active after accident is actually the easiest things to do, because it takes only a few days, and the impact is really important. Removing garbage, controlling invasive algae, controlling some hydroids that can be a problem, controlling predators such as Drupela and and crown-of-thorn starfish, controlling disease corals, at least monitoring the disease corals, but can break off the disease part of the corals, you know, and save some corals. Now they use antibiotic in the ocean, or they use probiotic, which we don't recommend, but this can be used. There are solutions that are coming slowly. Monitor bleaching, spawning, recruitment, educate and reduce pressure. So just by doing those things, you can actually have a great impact. Asexual techniques, so there is many. So planning it properly, to not doing during bleaching event, to not doing right before the coral is going to be spawning, for example, or right after the spawning events where the corals are a little bit weak is important. Planning your finance, make sure the natural recovery is not going to work first. If you tried coral gardening and if it's enough, that's good. You don't need to do anything else. Availability of fragment is always a key. I see a lot of projects starting without thinking where they're going to get the fragments from. So that's a problem. So then after they end up going and breaking a reef to restore another one. Use of nursery or not, it mainly depends on the quantity of fragment you're going to need and the quantity of fragment you have available. So if you have a lot of fragments available, then you're very lucky. Maybe you don't need to do nursery work. But if you have a limited amount of fragments, and then you need a vast amount of fragments to plant, you will have no choice than to go through a nursery phase. Direct or indirect planting, so meaning using artificial structure or not, or directly planting the corals on the reef, and then all the community involvement and education. Availability of fragments. So availability of natural fragments, and will you have to do a nursery? If you do a nursery, what kind of nursery do you have? Floating, rope nursery, rack, land-based nursery. You can get fragment. The main source of fragment, you know, I would say is development work. Everywhere they're going to build a harbor, everywhere they're going to build a GT, everywhere they're going to build a resort, you know, they will break corals. So going out there and getting the license to do it and getting all the proper authorization to do it and collecting those fragments and putting them into a nursery, it's often the best way to start a nursery. So you have to be aware of all the development projects that are going on in your area. So the step, set up a nursery takes 1 to 2 years. So you have to plan this ahead. You have to start nurseries 1 or 2 years before you start planting corals. So you need to plan carefully ahead and slowly start developing your nursery so they can grow big enough and you have enough fragment that will be available for your restoration work. Manage nursery genetic material. This is important to record all the genetic material, where the fragments are coming from, and multiplying the genetic of the same species is possible. And once you start planting and you start outplanting a lot of the same species, you remove it from the nursery and you mix and you start changing it, you know, with different species and different genetics. So the nursery production is not something static. It's something that is always evolving. So the species that are on your nursery should always keep on changing. So there is many different techniques. So my favorite is probably cement because it's cheap, it's easily available. You can use it underwater. The carbon footprint is not great though, but it's still, even here in Raja Ampat in the middle of nowhere, you still can find cement. Marine epoxy is great. It's made out of toxic material. It's a little bit expensive. So if you do a small work, it's great. But if you have to do a massive work, it's going to cost you a fortune. Cyanoacrylate works only for very small fragments underwater. So that can be challenging because microfragmentation underwater directly in situ requires a lot of maintenance. Nail and cable ties is an easy, so you need concrete nails, paku beton, and cable ties, and you put 2 nails like this. You put 1 piece of fragment in between, and then the cable ties in between. The cable tie, as you tie it, you're going to push the fragment on the rock. So this works very well. Coral clip, unfortunately, this is patented, but this is a nail with a spring on it that allow you to nail a fragment on the rocks. And stake and ropes, just using wooden stake and ropes on rubble works very well. So all this, all techniques have advantage and inconvenience. I try to give you some of the advantage of most of them. I like cement, so you can see the picture above, you know, this coral has been fixed on the mooring block, on the concrete mooring blocks using cement. So you can see that the cement looks very natural and disappear within the corals. The marine epoxy also looks very natural, even it's a very toxic material. It will get quickly covered by coralline algae and sponges and corals, etc., etc. And the concrete is, for me, the best material. We find that with iron and steel-based material, we have a lot of coral killing sponges, caninula, that is coming on top of it. So there is a little bit of few problems. Then after indirect planting, so microfragmentation only works if there is a lot of maintenance. So it's kind of a desperate measure, but it works for some particular techniques. Substrate stabilization is actually great because sometimes you don't even need to put fragment on them. So taking a roll of mesh and rolling it down the slope and putting on the slope, you know, you get quickly large area covered. So it's quite efficient on a steep rubble slope. And then artificial reefs out of concrete rebar or even mineral accretion technology, you know, show some results if they are put in the right location with the right species.
Vincent, you have 5 minutes left.
Okay. Not too far. So then the sexual technique. So I think Jimmy talked about it yesterday. So it's great technique. This is probably the future of coral reef restoration, but I don't believe that it will be the magic bullet neither. It will be great to restore the foundation of reef. Unfortunately, we need to sexually reproduce 500 different species of corals to actually restore the full ecosystem of a coral reef. So it will be great for the foundation, but we will still need to use conventional coral reef methods, you know, to actually put the genetic diversity into it and fix the massive corals and all the other species that you're going to need to increase the structural diversity of a coral reef. So the thing is this, every technique has advantages and inconveniences. Okay, so I like technique that can be used underwater because as soon as you take the corals outside water, you stress it and you lose a couple months of growth for the coral to recover from that stress. So as soon as you keep, as the most you keep the corals underwater, the better. So then the corals is not too stressed and will quickly start growing and quickly encrust and make a solid base. If you take them out of water, it works, but for 2 months, the coral will usually bleach a little bit, stress, and it will take a little bit of time for the corals to recover and adapt to the new environment. So often something that I see great methodology, I see everyday techniques using drones and everything, and people often forget, you know, the cost. And actually, unfortunately, it's a numbers game. And we need to find cost-effective solution if we want to restore very large areas. So it's not sexy. It doesn't please investors. It doesn't please donors. But in fact, usually the most simple technique is often the cheapest and often the best. So easy to make. So if you make something that is very complicated that you need to import in a remote location, that's going to add up to the cost and make the cost very expensive. So I always focus on locally sourced materials. So using rope that can be sourced locally, nail that can be sourced locally, cement that can be sourced locally, etc., are always the best material to use. Natural look. So coral reef restoration work, and you cannot see that it has been restored, for me is a successful coral reef restoration work. Doing increasing, huge artificial structure underwater, it's not very pleasing to my eyes. I like to see coral reef restoration work that cannot be seen. So natural hook, low carbon footprint. So that's one of the inconvenience, for example, of cement. Producing cement require a lot of energy, unfortunately. Works on different surface. So for example, the nail and cable ties are great in the Red Sea, for example, because the reef is very dense and you find very dense rock everywhere. But here in the Red Sea, in Indonesia, it's quite difficult to find very dense rock. You often have branching acropora, dead branching corals, and when you try to plant a nail into them, it just break. So it doesn't work very well. While cement will stick to almost anything, except on vertical surface. And then after, you need to select resilient and adapted corals. So the disadvantage using toxic material, such as epoxy or resin or cyanocrylate, we don't know for sure if it's going to be completely neutral on the long term. It can be neutral for a few years and it can become toxic after 20 years. So all the plastic-based, we try to avoid them. There is a lot of technique, unfortunately, that are patented. I think is a disgrace, that some people actually patent things that are made to restore coral reef. Some people are too time consuming, so it doesn't work on the large scale. Some people are too intrusive, bringing a big barge and dumping rocks on the reef, works, but it's very intrusive. So things that are not too intrusive and doesn't disturb all the fish and doesn't disturb all the animals that are already present, is better. We always going to the cheapest material and the cheapest technique, things that doesn't require high maintenance. If you can put a reef restoration work and you don't need to do any maintenance, that's the best you can do. Sometimes it happens. Easy access to predator, so that's a problem if the predator can quickly come. So if you plant directly on the reef, sometimes the crown-of-thorn starfish and the drupella quickly come, and they really like small stress coral fragment. And if you need special equipment that you need to import, it's never easy to bring to remote location. Then after, there is a long-term result, So mixing species close to each other will only result in competition. So this is always what I say. So that's why when I don't like when people, mix many species together, I always recommend, to keep in mind the adult size of a coral. A coral colony adult that will produce many eggs is not 20 centimeter wide, is few meters wide, and this should be our target. So this is a perfect example. We planted, so you have a red Acropora tenuis bifaria in front, and then you have a blue strain of Acropora tenuis bifaria behind. And then you can see that they will grow together, they will fuse together, create a large colony, and that will produce a lot of eggs. And you have a different phenotype from the same species right behind that will be able to fertilize each other. Even on the Acropora pulchra, the branching coral on the right side, you can see there is a purple strain and a green strain of the same species mixed together. For the record, this worked very well. But right now, the branching Acropora pulchra are overgrowing the plating Acropora, So I thought even by planting them together, they will be able to compete. So the Acropora, the red one, tenuis, managed to go out a little bit, but the blue one that is stuck in between, is actually dying because it's being overgrown by branching Acropora. So this is something that you have to keep in mind. Some corals grow much faster than the other one. Acropora are runaway corals. They try to overgrow everything else. So keep this in mind. And branching Acropora can be a problem after a certain time. It gives a very good result after 5-6 years. But if you plant them with other coral, they can overgrow them very quickly. So the long-term target is to produce sexually mature colony that will produce many eggs and source and send recruits to many other coral reefs. Then the maintenance, there is many steps. So I don't recommend people that are not trained properly, to start going on the reef and start removing things. You need to be trained properly to start removing crown-of-thorn starfish, for example. The main reason is to not getting stung yourself and discard them properly and removing them without damaging the reef and removing them only if they become a problem. So removing algae, especially before you plant or plant corals, removing predators, securing loose coral is already one thing that I recommend a lot of people can do. Replacing dead fragment on the nursery is part of the maintenance. Cutting out diseased corals is another one. Removing coral killing sponges is another part of the maintenance that you will need to do, at least at the beginning. Once the corals are big enough, then they can compete. I mean, they can resist Drupella, crown of thorn, and they can fight their own battles. But at the beginning, when they're still young and stressed, they need a little bit of help. Then after, the corals are only the foundation of coral reef restoration, unfortunately. And there is all the chain of animals that are above the corals and live within the coral that also need to be restored. And especially in Indonesia, with overfishing going on, so a lot of species will need to be rewilded. So they already started program of rewilding zebra sharks or leopard sharks in Indonesia, but unpaid parrotfish in places like Bali, Napoleon wrasse, that are very important in controlling crown of thorn starfish and Drupella infestation, will need to be reintroduced at some point if we want complete restoration. I put a triton snail. They should also be reintroduced at some point so they can control crown of thorn starfish, etc., etc. So not only we should reintroduce corals, but we should also reintroduce predator, herbivore, resilient species, resistant to higher nutrient loads, adapted to more intense weather patterns. So the corals is just the first step. There is a lot of work that will need to be done after restoring
spesies yang mencari spesies yang tangguh, tahan terhadap beban nutrisi yang lebih tinggi, dan beradaptasi dengan pola cuaca yang lebih intens.
And is a big part of successful coral reef. I see too many coral reef restoration that involve foreigners and involve dive centers. And unfortunately, this don't work very well on the long term. And I always highly recommend to only do this with kelompok nelayan or community involvement. They need to take ownership of their reef. That's key to the success of coral reef restoration. Education, so you need to start young. So you need to involve. Often it starts by teaching them to swim and giving them a mask and giving them the opportunity to actually access coral reef, because unfortunately, in places like Indonesia, most young students don't have access to coral reef. So this is a big part of the success of coral reef restoration on the long term. So this is few of our results, just to finish the presentation, so you can see, over 2 years in Nusa Penida, just using cotton rope and stake, we managed to get a pretty good result. And on the right, this is some boulders, that were restored in Ahmed, using just cement. So just doing small things, with small equipment, you can already achieve. You don't need technology. You don't need expensive equipment. You just need to go out there with cement, wooden stake, ropes, and you can achieve already good results. Yes, so I think that's the last one. So thank you very much. I hope I made it in time.